My name is Roger, and my Chinese name is Zhang Xiaoguang, and I come from ChinaMobile. And now I focus on NFV and cloud architect research. So now I will give you some introduction about NFV pre-integration. This is agenda. First, where the pre-integration idea come from? The second one is pre-integration concept. And the third one is practice in NFV trial project. So the first one. As you know, ChinaMobile has the next generation network target architecture. This is the target architecture. In this architecture, we have three elements. The first one is the TIC, which means telecom cloud nodes. And then the second one is new networks. This is the new networks, SDN networks. And the third one is new brands. As you know, our orchestrator, for example, ONAP. This is our new brands. That means the nodes, the TIC nodes, will connected with SDN controller. And all the TICs and SDN controller is controlled by the orchestrator, by the new brain. This is our target architecture. So next, I will introduce the important concept TIC, telecom integrated cloud. This is the internal architecture of TIC. At the bottom is hardware, and then the virtualization and WIM, and then the VNF and the orchestrator. Also, this is the SDN controller, which will be integrated into the cloud platform. In this architecture, we have, in fact, it is decoupling architecture. In this architecture, we have some decoupling principle. The first one, NFV software platform and the hardware decoupling. Then NFV software platform including virtualization plus WIM and hardware device different from the different manufacturers. And the two, VNF software and NFV platform decoupling. VNF software and NFV software platform from different manufacturers. This is two principles. And the next one is the module integration principles. TIC infrastructure have 5 modules. For example, in this architecture, we have the orchestrator, VNF, and WIM, and hardware, and SDN controller. So in our testing, TIC testing, we will cover verify the operator autonomy integration and compare with integration with CT and IT manufacturers. So this is our test content. First one, we will test the WIM and the virtualization test, include platform function, performance, and reliability testing. The second one is platform operation and maintenance management test. The 2 is business software testing. That's the VNF test. That's the VNF test, including the basic function test, basic business performance test. The third one is SDN controller testing. The fourth one is orchestrator testing. The fifth is software interface testing, includes the management interface test and WIM plus SDN test. So this is all our TIC architect test. We have about more than 1 year project time. So this is summary and analysis our TIC integration test issues. According to our NFV trial projects, we analyze the test result. In fact, integration-related adaptation issues between the components account for 55% of the total issues. Integration, so we mean integration is the key to the three-layer decoupling. This is our integrated system. As you know, we met some issues both for the components itself. For example, the VNF issues, NFV issues, and manual issues. And also, we have lots of integrated related issues, which means the issues between the two components. For example, this is integration adaptation 1 issues between the cloud platform and hardware. And the integration adaptation 2 is cloud platform and network and VNF. This is cloud platform and SDN, cloud platform and NFV or VNFM. All these issues is about integrated related issues. So that means, after we analyze these issues, we find integration will play a very important role in the in our target architect, and we should do as for the career, it will do put more effort on the integration. So let's summarize NFV integration. What means NFV integration? It means to integrate hardware, WIM, various type of VNFs, NFV, SDN, and other decoupled components into interrelated, unified, and coordinated system to form a complete, reliable, and effective overall system. These two features. The first one is the key to integration is to solve the interface, protocol, and configuration issues among various types of device and components. After decoupling, each component only provides its own optimization because it's owned by its manufacturer. But how to guarantee the whole system's stability, reliability, and performance optimization? That's depend on the integration. So we think this is what we think about the integration, NFV integration. Previously, I give you some introduction about the integration idea come from. It's from our network trial project. Next one, I will give you some introduction about pre-integration concept. Why pre-integration? In fact, what we defined is about the as-tick. As you know, in this architect, we have the core tick. Maybe we have dozens of core tick all over our country. And we still have many thousands of the as-node ticks. So our pre-integration only focus on this as-node. In fact, the pre-integration idea is come from the IT pre-integration field. We will face some challenges for the as-tick. The first one is challenge encountered in the three-layer decoupling system, because I don't know, our tick is decoupling with various components. So it's very complex and will huge workload. But so we have a question, whether we can get its repeat system deployment, automated integration, and testing. So this is challenge one. Challenge 2 is the deployment, because as you know, we have thousands of ads ticks. So it's very small and the scale repeatable. Can it be modularized, standardized, and batch deployment? That's our ideas, 2 ideas. So we defined our pre-integration system, which contains integration of hardware and software. The concept is, in order to meet the requirements of the deployment of ads nodes in a distributed architecture, 2 steps. The first one is a standardized and modular scalable telecommunications cloud. When pre-integration template is contracted based on given hardware and software resources. Secondly, mass production of integrated ads telecommunications cloud system based on the template. So the first one is build a template which include the hardware and software definition, and then we will mass production of this template. So there are 2 features. One is modular. According to requirements, that's, for example, that's the business requirements. Pre-integrated system template contains internal components and external interface are defined. And then the next feature is reproducibility, bunch production based on the existing templates. The third one feature is integrated delivery. So what we deliver is a box with the hardware and the software. So we want to we want it plug and play, simplify the integration of ads nodes and the rapid business deployment. So we will get a rapid business deployment. So this is our pre-integration content. The first one is build pre-integrated templates, and then we will instantiate a pre-integrated template. In fact, this step is system planning, and this step is deployment and test. In the system planning, we will give some detailed definition. The first one is we will get the requirements, for example, the ads of the server room and the ads VNF requirements. Use these requirements, or according to the requirements, we will design our software and hardware integration template. The template contains hardware system configuration, including server, storage, switches, and so on. Also about the software system comparison, include cloud platform, NFV, VNFs, and SDN, and so on. This is our system planning. After the system planning, we also get the pre-integrated template. And then we will instantiate the pre-integrated template. And we will involve hardware and software deployment and test and settings. Also do some automated integrating testing. This is our pre-integrated content. So let's summarize the pre-integrated delivers. This is so in our pre-integration delivery include both the software integration architect and the hardware integration architecture. The integration specialization related integration work concentrated into a pre-integration center. A professional and automated integrated deployment can be realized. The tool is software and hardware integration solutions, including hardware devices such as servers, storage, and switches, as well as software one, for example, the virtualization cloud platform, WinF's NFV, and other software system. They will be delivered as a box and packaging ready to use. The third one is online simplification. When a pre-integrated system is deployed to a ads node, there are only two interfaces to the outside. Only two. One is power supply, and the other is network interconnection. The power supply is relatively simple, and the network connection needs to be defined in advance according to the system operation and maintenance management requirements and the WinF communication requirements. So this is our process. We will have first in pre-integration center, and this is the local integration of ASIC. First we do is the planning, plan the resource and the network, for example, the hardware and software. This is step one. Step two is deploying and testing. Includes the deployment of NFV, deployment of WinF, include manual in the Cortex. And after that, we will do the system testing. And then the step three in the local ASIC. Because at this step, we do the one box delivery. So it's simple operation in the ASIC. Only power on the whole system and connecting the NFV to the internet, and then start the WinF applications. And then to the step four, for the ASIC, it only have some local spot on the hardware, for example, server network and so on. At the pre-integration center, it has the multi-layer cooperation and the remote operation and the business expansion based on the amount of subscriber. So most of the workload is on the pre-integration center, and the simple operation on the ASIC. This is overall of pre-integration system. As you know, in our country, we will have some integrated verification center, and in every province we will have a provincial integrated operations center. In these two areas, we will do the pre-integration verification, and that means we will define our template, pre-integration template at these areas. Then we will deliver our at this area we will do the production based on the template. After that, we will deliver our TIC product into every local site of ASIC. So the last one, I will give you some introduction about the practice in our project. So we also follow the steps which I have already introduced. The first step is build pre-integrated systems in our lab to form a pre-integrated standardized process. We have three steps. First, we complete the pre-integration template definition, and then complete the template instantiation, and then summarize the formation of internal and external field standard operating procedure. After that, we do the as local integration delivers plug and plan, and the new services, that means the WinF business are quickly online. The pre-integrated system is powered down in the lab, and then the entire requirements is transported to the local edge node. It can be powered on and involve a small number of external network configuration. And then VNF service can be online quickly and work fine. This is our practice process. So in this process, in fact, we have the 3 steps. First is pre-integrated template definition, and then template instantiation work, and then integrated system delivery. I will give you some introduction one by one. This is pre-integrated template definition. What means our template? As you know, about introduction, in fact, the template definition is very important. Is the key step in our process. So in the pre-integrated template definition, the first one is system internal modular definition. In fact, in the pre-integrated system internal structure, we have these components. The hardware, for example, in the template, we will define the detailed information about the hardware. For example, their type, their number, include the server, storage, and the network devices. And about that, we will give the definition about the cloud platform, also about do some planning of the cloud platform. For example, how about the compute, how about the network definition, how many networks, how many sub-networks, such kinds of information definition. Also, we will have the VNF's definition about the number of various of components in every VNF, and VNF network planning, VNF resources planning. This is the VNF's definition. Also about the NFV, which we will have the number of IT resources applied for the NFV, and the NFV deployment patterns and other informations. For example, in our practice, most of FVO deployment use the active standby mode patterns, such kind of information. And the two is internal and external standard interface definition. This is very important for our system. The first one is external network communication. In this area, we have the 2 definitions. One is management network plane, include the cloud platform management, for example, management network plane. For example, our WIM OpenStack platform network plane. Another one is VNF management. In our traditional VNF, it's about EMS. This also is about the OSS connection. This is our network management. The second one is VNF business network plane. As you know, every VNF which run on our cloud platform should connect with the outside with other components. For example, in EPC component, maybe it will use the outside HSS component. So the VNF on our platform should connect with outside HSS. So such kind of communication interface. This is external network communication. Also, we have the internal network interface. Internal network interface between the WIM and the WIN-FM, WIM and NFV, and the WIN-FM and NFV. This is the pre-integration internal and external interface definition. The third one is the computer room environment interface definition. As you know, our production will deliver to the edge node. So that means our system should be suitable for the computer room in the edge stick. This is at this area we should define the server racks, power supply, and skill, such kind of information. So this is our overall template definition. Step 2 is our instantiation about the template. In fact, in these areas, we should deploy the real systems. For example, in the hardware, we use multi-node servers, and we use ZTE, VIM, and hypervisor, and use VBRUS, VNFs, and VEPC. In this architect, you may see for the hardware uses, we use 12 compute nodes, 3 storage nodes, and we also have the 2 control nodes. For Ericsson VEPC VNFs, because it uses hardware, to bare metal for its VNFM deployment. So this is Ericsson VNFM usage of the hardware. And we still involve the 6 switches. And this is ZTE-VG is a router. Is a router in these systems, which will take the role for the internal system to the external system. This is hardware usage. And also we have the cloud platform. In cloud platform, we should do the resource planning for the VFO, NFV, VFM, and WIM. Of course, also the VFM servers for the Ericsson VFM. And the next one is the network planning. In network planning, we should do the divided the network into management plane, storage plane, and business plane. This is the cloud platform. And the third one is VNFS. In our system, we involve the ZTE VBRUS and Ericsson VEPC. So that means FVO will unify the scheduling, the network planning, and delivers the VNF version package to the VFM and WIM. That means these 2 VNFs will managed by one FVO. The last one is an FVO. FVO resource requirements as 2 WIMs. This one. The 2 WIMs deployment pattern is active and standby. So require 2 WIMs, and the VFM also require 2 WIMs deployment pattern is active standby. Also about the Ericsson VFM, it deployed with active and standby model. In fact, in FVO deployment model, FVO is manual deployment model, and the VFM with this VFM, the ZTE VFM, can be automatically deployment using FVO template. But this one, the Ericsson VFM, it is also manual deployment mode. So this is our installation process based on the template. The step 1 is the integration system delivery. This is the hardware mode of the system. In our delivery, we include 4 multi-nodes servers with 2 racks. This is all the resources. For example, VBrush from the ZTE use 4 VIMs, and VEPC use the 16 VIMs, and NFV use 2 VIMs, and VNFM for the Ericsson VNFM uses the 2 bare metal machine, and for ZTE VNFM uses 2 virtual machine with active standby deployment. And totally, the server use is for the compute nodes is 18, and the storage nodes is 3. Okay. Also, in this system, it contains some switches, 10-gate switches and 1G switch. And also, this is the storage type multi-node server, and this is the compute type multi-node server. And also about this rack. Just like this morning, keynotes introduced, just like this one, is one rack. Includes the switches, compute servers, and the storage servers. Yes, the whole system which we will deliver just like this. So let's give you some summary about the key point of this process. The first one, as you know, we should do the bunch production about the thousands of the ticks, the edge ticks. So the first one we should do the standardizations, system internal integration standards. For example, the cloud software, hardware, and hardware. Software and software includes WIM, and VNF, VNFM, and NFV, and WIM. Also, we should do some system external integration standards. For example, the network, electricity, rack, and rack. And the third one, we should do some standardization of internal and external network definition. The fourth one, we should do the standardization of operation and maintenance interface. All these components, all these items, I think we should do the standardization. Based on the standardization, then we will get the automation, and then the intelligent. How about the automation? The first one is automatic integration test tools. In fact, we now do some deployment about the integration test tools, and to get the automatic integration. And then we will do the remote operations, include the flexible scaling of automatic services on demand, rapid deployment of new services. And the last one is also very important, remote maintenance, monitoring, maintenance problem processing. So this is our key point of summary about our integration. So as you know, OpenStack is now mature at this point. And in the telecom business, for example, in ChinaMobile, we involve more and more systems on the OpenStack-based cloud. Not only our private cloud, but also our telecom business. We have do some trial network project about 3 years. We have do lots of tests, different components. At the early years ago, it's not very mature. For example, because the system is decoupled, and with the components is supplied by the different manufacturers, and we don't have the exact demands for the interface between the components. So there are lots of problems during a lot of issues during the integration. So after 3 years trial, our network trial, we realized that the integration, if we want to do the decoupling system as our TIC definition, we do lots of work on the integration. Then we will get a perfect whole systems. So integration is very important. And the next one is operation. Operation is also very important. So I think maybe we still should involve several years to do a good integration and perfect maintenance and operation. This is only one practice in our process. Sorry. This is only one practice in our NFV process, but I still think it have some long way to go for our NFV road. Yes, thank you very much. Any questions? Yeah.
Require the same stack underneath, or do they want to specify hypervisor? Can they both share the same hypervisor, or do they want dedicated clouds for those VNFs?
You mean
because can I share the resources?
Yes, very.
Resources across multiple DNFs, and will the vendors will support multiple hypervisors, or do they want to specify what hypervisor they want to use?
Yes, good questions. In fact, at our earlier times in our practice, every VNF want to have the dedicated resources for their business. But now, we have some common demands for the VNFs. That means in the cloud platform, we will have some, we will give their capabilities. For example, what kind of compute capabilities, storage capabilities, and network capabilities. We will show the standard capabilities to the business. So the business should, if their VNF is not adapted for this cloud platform, the VNF should do some modification itself. But with another way is for the cloud platform. The cloud platform is also will summarize the common features and common requirements from the VNF. For example, as you know, in our in our telecom business, have some reliability requirements and performance requirements. So we support the DPDK, SLV, such kind of acceleration measures to for the systems. So I think this is how to fix the issues between the two components. Both do some efforts about the cloud platform, also about the VNFs. Okay. Okay, the time is. Okay, thank you very much.